Here we have this equation, 4 cosine 2x equals negative 2 root 2. We're going to solve it graphically and then we'll do it algebraically. And graphically, we're going to graph y equals 4 cosine 2x, and we will graph y equals negative 2 square root of 2. Starting with 4 cosine 2x, we know that the amplitude is 4. We know that there will be 2 complete periods in 2 pi, so 1 period will equal 2 pi over 2, or pi. So we'll have pi 2 pi. I'll erase this one. Now we talked about this in terms of determining what these numbers are. We have the length of one interval equals 1/4 of the period, or in other words, 1/4 of pi here, which is pi over 4. To review, why is it 1/4? Because a complete period or a complete cycle will take 4 equal intervals. 1, 2, 3, 4. We know cosine starts at its high point, so it's going to start at 4. Once it's at the high, we could go high, mid, low, mid, high, and we could just keep on repeating that: mid, low, mid, high. I forgot to label these numbers. This will be pi over 4. The next one will be 2 pi over 4, which reduces to pi over 2. The next will be 3 pi over 4. And then we have pi, and we can label this one here as 3 pi over 2. At this point, we just connect the dots as best you can. Trying to do your best to keep that as a curve going through. Now we have y equals negative 2 square root of 2, and we know square root of 2 is about 1.4, so this is approximately equal to negative 2.8. So we're going to go a little bit past negative 2, before negative 3, so how about there? For what we're doing right now, it's not so critical that we get that value correct. We'll label it as negative 2 root 2. We can see that there are 4 solutions. I have these two and these two. Now let's solve it algebraically. First thing we'll do algebraically is take our 4 cosine 2x equals negative 2 square root of 2, and we'll divide by 4 to get cosine of 2x equals negative square root of 2 over 2 after I reduce. We draw our unit circle. And we have, where is cosine equal to negative root 2 over 2? What is cosine on the unit circle? Cosine is our x value, and negative root 2 over 2 is about negative 0.7. So we'll come here and we'll draw a line at negative 0.7 for x equals. We can see that we have 2 solutions here, and since you are experts at the unit circle, you know that we will get 2x equals, this value, the first value will be 3 pi over 4, and we'll have 2x equals 5 pi over 4. Now what am I missing? I'm missing this plus 2 pi n plus 2 pi n. Why do I have to include plus 2 pi n there? Because the period of this graph has changed. It is not 0 to 2 pi. It doesn't have a period of 2 pi. Right now, we found out earlier that it has a period of pi. Now let's see what happens when we solve for x. Remember, we're not going to divide by 2. We'll multiply by the reciprocal just to prevent any mistakes from occurring. So we'll have 3 pi over 8 plus pi n. And over here, now that we know we're doing 1/2, we can just say it's 5 pi over 8 plus pi n. We want to have a common denominator, so what we can do is just write 8 over 8 in front of there. At this point, we can start listing out our values. Our first value will be 3 pi over 8, and our second will be 3 pi over 8 plus 8 pi over 8, which will give us 11 pi over 8. Our next set will be 5 pi over 8, and we'll add another 8 pi over 8 and have 13 pi over 8. What would happen if we add another 8 pi over 8? We would get 19 pi over 8 for this one, and we would get 21 pi over for this one, 21 pi over 8, which are outside of our domain for which we're solving. So we have our answers. They are these four. Now let's compare those to the graph that we did. This first answer here will be 3 pi over 8, and this next one that I circled will be 11 pi over 8. If we traverse the graph, what is that distance, the horizontal distance between those two solutions? That will correspond to pi, which is our period. And if you're looking at our equation, notice that we end up having pi n. Our next set, 5 pi over 8, will be right here, and we'll go around and we'll get the next one, 13 pi over 8, and again, what's that horizontal distance? As we go from one solution to the next, it will be pi. Let's see about doing one more. This time we'll take -3 sine of pi over 4x equals 1. We'll also solve this on the domain from 0 to 2 pi. We know that sine starts in the center line. There is no horizontal shift here. What we're going to do here is graph -3 sine of pi over 4x, and we'll also graph y equals 1. We know our amplitude is 3. We know pi over 4 periods equals 2 pi. So when we multiply both sides by 4 over pi, we'll get the period is 8. So that means what we're going to do is finish up. We can count 1, 2, 3, 4, 5, 6, 7, 8. I already had these pre-labeled. Now what are our key values there? Just like we did before, we'll say 1/4 of 8, which will be 2. So the time it takes, or the horizontal distance it takes to go from a high to a low, or high to mid, or mid to low, low to mid will take 2 units. So we're starting at 0, the next one will be at 2, and we're at mid, and there's a negative this time. We know normally sine goes up, but since there's that negative there, we're going to be going down first. So we're going mid to low, and we'll go back to mid at 4, and we go 2 more, 6, we'll be at a high, and then we'll go to 8. So now we can connect the dots the best we can. One thing we could realize is that this 8 is beyond the domain for which we're solving. We're solving from 0 to 2 pi, and we know 2 pi is approximately 6.28, so what we're going to do is end up stopping around here. Now we can graph y equals 1. That'll be, this again isn't so important to be perfect on it. We can see at this point we're going to have one solution in that domain because the other one will be outside. Let's go ahead and solve this algebraically to make sure that we get that same thing. We have -3 sine pi over 4x equals 1. Divide by -3, so we have pi over 4x equals -1/3. Set up our unit circle. On the unit circle, sine is our y value. We're going to go about -1/3 of the way down. So we'll have 2 values here. Now, is this a unit circle value of -1/3? Hopefully we recognize that no, that is not. Slide this up a little bit. Hopefully we can see the calculator. So what we're going to need to do is say pi over 4x equals the inverse sign of negative 1/3. Let me turn on my calculator. And so make sure I'm in the proper mode. Yes, I'm in radian mode. Let's see, that's a little bit better there. I'm in radian mode. Now I can go back to my home screen and I'll type in inverse sine negative 1 divided by 3 and hit enter. That gives me negative 0.34 approximately. And we'll say we have to include all the coterminal angles. We're going to say plus 2 pi n. Now that's given me this one down here. How do I go all the way to this one? Well, you can see here this angle will be also 0.34. We have half the circle is pi. So it will be pi. One way to do it is just to say pi plus 0.34, or if you want to stay consistent with how we've done it before and say that it's pi minus 0.34. Now remember, on your calculator you're not going to use this rounded number, and we're going to say plus 2 pi n. Got to make sure we include that. There, we can see that. Now, just for safekeeping, what I would like to do is I'd like to store this number in my calculator. Let me move the screen up a little bit here. So the way you're going to get the store is at the bottom of your calculator, there's this button STO. Press that. Let's see what happens there. We get answer, arrow. Now what we're going to do is press the alpha key, and you'll see this A flashing on and off. And we can pick any letter we want. Just for simplicity, I'm going to pick A. I hit enter. So now anytime I use A, that number is there. Let's deal with this other set. I did not write here pi over 4x equals that. And over here I'll also have pi over 4x equals this. I'll put a comma there. Let's deal with this. We can say pi. So we bring up our pi minus answer, because our answer is negative there, and that should give us a number more than pi. It does, 3.48, rounded to 2 decimal places. So we'll say plus 2 pi n. We have pi over 4x equals that. What are we going to do with this? We're going to multiply everything by 4 over pi. So on my calculator, I'm going to hit times 4 divided by pi. And I'll hit enter. So this is going to give me x equals 4.43. And when I multiply 4 over pi to 2 pi n, I will get 8n. Now here we have one solution, 4.43. What happens when we add 8 to it? We get 12. That's outside of our domain, so that's not going to be a solution. Let's see what happens on this one. See, I will need my calculator back. What I want to do is multiply negative 0.34 by the 4 over pi. So what I need to do first is bring back my A. How am I going to do that? I'm going to press alpha A. Now I can press times 4 divided by pi, enter, and I get this number, negative 0.43. And again, when I multiply 2 pi n by 4 over pi, I'll get 8n. Now, is negative 0.43 in our domain of values that we're solving for? No, it's not. So what we need to do is hit plus 8. So we can just type in, hit the plus button, and it says answer, and we'll 8 equals, and it gives us this 7.57. 7.57. Now, is that inside our domain? No, that is also not in the domain. So this side of the solution didn't give us any answer. So according to our algebraic solution, we have one answer of 4.43. Now we look at our graph again. Does that agree with our graph? Yes, we only had one because when we came over here, this other one is our 7.57.